Hello everyone, this is Sohrab Aftabjahani from Intel Corporation. I'm a senior staff security researcher and product security expert. I give an overview of security annotation for electronics design integration, SA-EDI standard today. I represent Accellera IPSA working group here. This work is with valuable contributions of the IPSA working group. Security risk is growing. Global cyber revenue has passed $1.5 trillion. Cybersecurity breaches has had an increasing trend, even like 11% increase in 2019. Meanwhile, the hacking toolkits have become more affordable, even less than $200 now. We have seen frequent ransom attacks, like even 14 every second, and common vulnerability enumeration shows an increasing trend, a lot more vulnerabilities in 2017, 2018, 2019, if you look at this plot. We live in a connected world now. Many forms of connectivity exist around us, including peer-to-peer, device-to-cloud, and cloud-to-cloud forms, and platform as a service and software as a service are now more popular. Please note that the current complex systems have many elements and their security has multiple dependencies and many assumptions. Hence, security assurance is required in addition to functional correctness, as breaking each of the chain elements can break the security of the system, causing issues like denial of service, escalation of privilege, information leakage, and code execution, and others. Shorter product time to market and better product economy increase the demand for IP reuse. As you see in the plot, even IP subsystems comprising of many IPs follow the same trend of increasing reuse. Third-party IPs are among enablers for creating subsystems faster. Unfortunately, all can lead to increased security risks due to increased security risk of more complex systems, increased exposure as the result of free use, and increased unknowns because of using third-party IPs as black boxes with respect to security. There are some existing work to address security or impact security, but none of them cover security assurance for commercial off-the-shelf IPs, including the common criteria, the open trusted technology provider standard, the functional safety for automotive information security management system, application security. The last one is the closest, but does not address hardware, and it has been installed. 21434 addresses hardware components, however, it does not dive at the IP level. The initial scope of the IPSA working group is to define an automatable, systematic approach that can be consistently supported across multiple target implementations. The working group will focus on existing standards that pertain to RP specification, design, verification, and integration where security risk is a concern, as well as known security concerns that have been identified by either industry experience or security researchers. Currently, we have 60 members from 18 companies and 1 university. Our work group meets bi-weekly on Tuesdays. Accellera is an independent, not-for-profit organization dedicated to create, support, promote, and advance system-level design, modeling, and verification standard for use by the worldwide electronics industry. The mission is to provide a platform in which the industry can collaborate to innovate and deliver global standards that improve design and verification productivity for electronics products. We established the IP Security Assurance under Accellera in 2018. The initial scope for the IPSA working group is to define an automatable, systematic approach that can be consistently supported across multiple target implementations. The work group will focus on existing standards that pertain to IP specification, design, verification, and integration, where security is a concern, as well as known security concerns that have been identified by either industry experience or security researchers. Currently, we have 16 members from 18 companies and one university. Our work group meets bi-weekly on Tuesdays. The IPSA agenda is as follows. The scope is currently concerns with integrating hardware IP into embedded systems like SoC. Our concerns are what exactly is being integrated, what are the risks, how to verify the completeness, accuracy, and overall quality of a supplier's security assurance collateral. Our focus are on A, existing standards that pertain to IP specification, design, verification, and integration where security is a concern, and B, known security concerns that have been identified by either industry experience or security researchers. Our stakeholders comprise of IP providers, EDA vendors, and IP integrators. Anything else, such as establishing trust between the stakeholders and establishing trust in the supply chain, like hardware, Trojan, horse detection, are out of our scope. We released the IPSA proposal as a white paper in 2019. It includes the following: methodology, the overall concept and workflow along with individual components, dependencies, and assumptions, common IP security concerns, enumeration, SIPC, a knowledge base that lists potential IP security concerns in a similar manner as common weakness enumeration. Open core examples highlights how the methodology applies to real open source cores, and summary and outlook, which captures the next steps required for public release of the standard and roadmap. Later, we had a major update in methodology and migrated SIPC to CWE. Here I give you a brief introduction to CWE for those who are not familiar with. CWE is a formal list of known weakness types. It provides a common language to describe security weakness in architecture, design, or code. It can be used as a standard measuring stick for software security tools targeting those weaknesses. It provides a common baseline standard for identification, mitigation, and prevention efforts. It began with a focus on software weakness, now more than 800, and has published several iterations of the top 25 most critical software errors. Now it has expanded into hardware weaknesses, more than 95 in the version 4.3. CW compatibility program recognizes products or services that leverage CWE with industry partners, including some of us. CW expanded into enumerating hardware weaknesses and is seeking further collaborators and contributors to help grow the effort. For further information, please contact MITRE directly. Now I introduce the SA-EDI standard to you. Having an IEEE standard is the end goal. Its draft has been completed with 45 pages. We had the Accellera public release in July 2021 with 21 authors and 11 companies, which is available online through Accellera. We had this EDA companies, proof of concept, and demos at Design Automation Conference 2021 by Tortuga Logic and Methodics. Objectives of the SA-EDI are as follows: improve trustworthiness of IPs and IP providers, assist IP integrators in understanding and reducing security risk, accelerate tool development to enable scalable security assurance. For properties, we use JSON data modeling, by which the required fields help consistency and expansion supported for proprietary information. We bind the data objects to RTL, which is both automatable and verifiable. The properties are outside the design, so they can be applied to existing IP. Please note that this form of modeling is very low overhead and requires only 4 data object types. This picture shows a typical IP development flow in which IPs are designed based on IP standards, and through EDI tools they are validated, synthesized to netlist, and verified again for physical design. And the design files like Verilog, VHDL, system Verilog, source files, netlist, and verification test benches are delivered to the IP user as a bundle. In today's existing IP delivery flow, IPs do not include an annotation for security. SA-EDI enhances flow for IP delivery integration. Here, IP providers generate and include annotation for security, and integrator receives security annotations. With the SA-EDI, we generate several data objects to be augmented to the bundle to make it security aware. Here in the green boundary, you can see the database object using the CWE asset definition object, and element object, and attack point security object. The IP providers generate them and provides them to the integrator to be used for integration for security and security verification. Now I give you more details regarding the 4 object types. A database object is generated manually and includes the key attributes defining a security weakness database, such as CWE. An asset definition object is generated manually as well, and it's actually the root object that identifies assets in the IP. Here, an asset refers to anything of value importance based on our security objective. An element object is generated automatically. It identifies input, output ports, and configuration parameters that can influence and/or observe the asset. An APSO attack point security objective is also generated manually. It assigns security objectives such as confidentiality, integrity, availability, and attack points of the elements to an asset. It also identifies conditions that might violate this security objective. In this diagram, you can see the 4 data objects with their fields and their associations. The data object include an ID to be used in the asset definition object. An asset definition object includes fields such as name, family, type, and database ID. An element object includes fields such as asset name, ports, parameters, and CW references. An APSO object is like an element object, but ports are replaced by attack points. We can have n database objects for one asset definition object, in CWE family types for one asset definition object, 2 element objects for each asset definition object, an APSO object per pair of the elements objects, and n CW references per pair of the elements objects. On the receiver side of the IP bundle, an IP integrator reconstructs the elements and compare it with the elements supplied by the IP provider, and add or remove security objectives in the APSO on need basis prior to going through verification for the mitigations. This slide shows the algorithm that an IP integrator should follow. 1. Verify the existence of the SA data objects. 2. Using RTL source and asset definition object regenerates the element object E star. 3. Compares E star with the element objects in the IP bundle E. If E equal to E star, then collateral matches RTL, use IP. If E not equal E star, then stop. RTL SA collateral is out of sync. 4. Decide which APSO objects are in the scope of the SOCIC. This becomes part of the product's threat model. 5. Identify additional APSO objects for integration. This becomes part of the IP threat model again. Finally, performs verification on the threat model. Now we demonstrate how we can apply SAIDI to an example. A simple watchdog IP from IP core is chosen here. Uh, it's configured through Wishbone interface. There is a write protection log feature. There are non-standard debug signals. Here, the asset is a 16-bit counter in module COP_count. Instead of block diagram shown previously, we need to use actual signals used in RTL. This simple timer has two interfaces, 8-bit bus to access registers, debug signals which override registers. There are 8 wires buses in total. The WD control RTL model configures and controls the timer. The counter RTL model is the timer. In step 1, we identify the assets and knowledge base. We answer the following questions. What's critical to proper functionality? Does the IP have any security objectives? CIA. Here, WD timer, the timer value, and WD assert timeout. That's actually the timeout value are assets of interest. Here we see the asset definition objects in JSON. Please note the hierarchical names for WD timer and WD assert timeout for each object. The description fields, family, type, and database are the same. And the description field is timer, count, state. This critical for proper operation. And the family fields include counter, timer, and test debug. And type field includes control and critical, and database refers to CWE view hardware design. The database object in JSON is as follows. There is an ID text field set to CWE view hardware design. The description is also a text field set to a community developed list of hardware weakness types. The URI here refers to CWE entry MITRE website, and the CWE version 4.3 is used. In step 2, we generate element object pairs. The left one is for signals influencing the WD timer as input, and the right one is for signals that the WD timer influences as output. Please note that the 3 CWEs references for both and the ports and parameters listed for each element object. We generate the element objects for the WD assert timeout similarly. The left one is for signals influencing it as input, and the right one for signals that it influences as output. Like the first pairs, the corresponding CWE ports and parameters are listed for each element object. In step 3, we generate APSO objects. Here there is a name field for each security objective. The same name in the element object is used here. The security objective field is set to integrity. In the description field, we read, if the lock bit is not enabled, then the counter can be altered. A condition is given as highlighted. As a logic expression in Verilog, the condition should not happen to guarantee the integrity mentioned for this security objective. The listed CWEs are the same as that of the elements object. Again, attack points and parameters are listed. This one shows the APSO security object number 2. Here security objective is integrity of WD timer. The expression showing that if its debug enable is 1 is the condition to violate the integrity of the WD timer. The corresponding influencing signals, attack points, and parameters are listed as well as the CWs. We follow the same process for WD assert timeout to create these APSO objects. Here the signal name, the security objective, and its violation condition are highlighted. The description field explains the possible issue as debug can assert a timeout at any time corresponding to the integrity violation condition. This one is the last APSO object for the WD assert timeout, security objective 4. This is similar to the last one, but the issue is different as mentioned in the description. Debug can assert a timeout by setting count value to 0. Likewise, the corresponding attack points, parameters, and CWEs are listed. In step 4, we create IP bundle, which contains the following: 2 asset definition objects, 1 database object, 4 element objects, 4 APSO objects, and RTL, netlist, and other things. In step 5, integrator verifies the bundle by generating the elements objects from the provided database and asset definition objects and RTL in the bundle, and comparing the elements star to element in the IP bundle. If equal, then continue. If not equal, then stop. RTL does not align with the SA-EDI objects. In step 6, integrator defines the threat model by deciding which APSO objects are in scope, finding additional APSO objects if needed, and creating integration verification tests for security objectives. For example, here an additional security objective number 5 has been defined as the availability of the WD underscore assert underscore timeout, which is defined as the timeout assertion should never be gated. As I mentioned, Methodix, a member of the IPSA working group, demonstrated implementation of the SA-EDI in Design Automation Conference 2021. Here you can see that their tool automates security information exchange using identify assets and known security weaknesses. It also uses Perforce to catalog the IP threats and objectives. On the integrator side, it performs verification and analysis of the security objectives. In the same conference, Tortuga Logic demonstrated its own implementation of the SA-EDI in Radix. It generates SA-EDI objects. It verifies the security concerns in the SA-EDI data objects. On the integrator side, it regenerates SA-EDI elements for verification and verifies the claimed security mitigations. This table shows the IPSA roadmap. A standardization document were released in mid-2021. In Q4 of the 2021, SA-EDI was demonstrated for 288 tools in DAC 2021, and the one-pager SA-EDI introduction was created as part of the supplemental materials. In 2022, we are supposed to formally start moving the standard to the IEEE standardization process and to complete and release it by the end of 2023 per our current plan. By the end of the Q1, CW REST API to make CWE accessible as a service with a standard interface for tools has been planned to be completed. MITRE, CW REST support, and EDA tool compliance should start from Q2 and continue to the rest of the year. I close this talk with a summary. SA-EDI is low overhead and non-disruptive as it is defined outside the design. It uses simple reference tags, JSON, and minimum tooling is required. SA-EDI is also flexible and scalable as it can be applied to existing designs and is extensible. SA-EDI can be automatically generated and is verifiable as it enables EDA tools to generate it and verify RTL match and security annotation collateral. Please consider joining IPSA working group as we work on creating an IEEE standard out of SA-EDI. Thank you for your attention. Please feel free to visit Accellera and MITRE and contact them using the links and the email addresses below. I will be happy to answer your questions, if any.
How do we join IPSA work group? Is there any requirement or anyone can join it?
Yeah, I think it's open to everyone. That's a standard group. Then you can actually contact the chair. And if you visit Accellera, you will get more information. And I just don't know if I can share the email here, but any more questions?
Hi, I have a question. It talks about the IP bundle, and how does it like relate to the IP exec? Like, can we use IP exec with SADI as well?
This standard is independent of that one. Then if you use IP exact, you can use for that purpose, that specific purpose. Here, you will use this just to capture the security related information. Then this is an independent standard.
I have a question regarding the use of the standard. Is it mainly at the RTL level once the implementation is decided, or can you also derive those properties at the specification level?
Currently, what we have is at RTL level. At the specification level, I think it could be applicable, but it's not going to be automatable. And at this point, and but you need to write your specification maybe in a form of executable code, and then you may have that executable code to be translated to RTL. It's at this point it's not supported, but you can apply it. There is this question here. How does the integrator creates the verification test for security objectives through system Verilog UVM? For the integrator can write the test in any languages that or any methods that they know, and there is no limitations on that. If you guys want to use formal, you guys can use formal. Yeah, sure.
I've got a question about the use case. I don't think you expect us to manually type out the JSON file. It's like no one would want to type it. So is there any tool that to help us create that file? Something that look at my code and just output what the weakness are, and so I don't have to type it up?
With respect to the typing, that's a data structure that needs, and depending upon the automation of the EDA tools, they may give you maybe some forms that you fill out the information. Then I think up to some level, maybe the tool can generate some of the information for you. But whatever you give as the input, I think you have to type it yourself. Then it really doesn't matter if. And the simplest form is to type them like in with using a text editor, using a format that's supported using JSON. And then
if
also
someone have to type it in and someone to manually read it as well, then it can really tie to our tools, right?
correct. And that's why we have used JSON. We could decide using XML. It could be readable, and also for machine, the machine can read it. But it has some tags. It's like looking at like the HTML code, and that you can still see the codes, but it has a lot of unnecessary information for formatting other stuff. And here the intention was to have something that both you can read it, modify it, and also machine can read it and process it. And again, I emphasize that some of the information are like input to the tool. Then if that's input to the tool, you cannot have the tool generated, because you define, like for security, you define what are your assets, how you guys want to protect them. And up to some level, for the how part, the tool can support it depending upon automation. But you give some expressions that actually in your apps objects, that what happens if the security objective is met or is not met. Then that depends upon the level of the automation provided. Then for the input, data objects or data structures, you need to input them to the tool. And for some of the things, depending upon automation, maybe the tool can generate for you. And that's then those are dependent upon the capabilities that the CAD tool provider provides to you guys. But the point is, we have like a portable format to annotate the security information. That those are generated actually for the IP, and also given to the integrator, and the integrator can use those to make sure that the claims for the security are met, or they can actually add more security objectives at the integration level if they need to add some more.
So does the work group only work on the file format, or does it define the CWE list definition as well?
Actually, for the CWE or similar databases, currently we give a link to those, and the tool is supposed to get the database and process it. And then actually we do not do that ourselves. And then on implementation, the CAD tool provider can actually get that information and process them. Then suppose that you're using a specific IP, suppose that it's related to graphics, and then with CW you can actually bring it the list of related CWEs, then you can include them here. And then in my opinion, it's a little bit open at this point. And with the current implementation, as far as I know, it's all done manually. Then you just give them as the input.
So how is this work group relationship with the CWE, the hardware CWE SIG then? Then it seems like you two are supposed to be really close work together, right?
Actually, there is a connection now, and actually there is a subgroup who's working on enabling having a service from CWE just to provide such information like the CW database, or maybe do the query on their database to get the related information for the EDA tools. Then altogether, you should be able to get the database or maybe do a query to get some part of the database, depending upon what you need to query.
Oh, thanks a lot.
Sure. That's the, and I think I mentioned that this standard is going to push to become an IEEE standard, and then the work has not been completed yet, and then there are some enhancements coming. Yeah, then also you guys can feel free to join the IEEE standard. This is the open to everyone. I think for Accellera, the limitation is the company needs to be an Accellera member. When it gets to the point that we have an IEEE standard, as far as I know, it's open to everyone, even there is not such a requirement. I think someone asked that who can actually join the this working group. There is a limitation, and the limitation is your company should be an Accellera member, and then there is, I guess, some membership cost for the company, but I think it's not going to be something prohibitive. Then if your company is not a member, you guys can reach Accellera, maybe become a member, then join the group. You guys can check with Accellera. I think this is something that I'm thinking it should be like this. But as far as I know, if you want to get access to the Accellera portal, you need to be from one of the member companies at this point. Any more questions? Yes, and I have some correction to talk about, and actually, I think for some reason one of the slides was not shown properly, and then let me see if I ask from moderator to go to a specific. Can we go to any specific slides from there? I'm asking the moderator. No. I'm asking Aiden. Okay, just a moment. Let me.
No more questions.
Slide, just a moment. Slide 16.
I only have the recording. I don't have your actual slides.
And can I present it or not?
Yes, you can share your screen. There's a toolbar on the bottom of your screen.
Okay,
and
okay.
In green, you'll see it says share screen.
Okay, let me see here. Share, let me just quickly share the screen. Yes, for some reason. Yes, do you guys see my screen now?
Yes.
Yeah, it should show this industry technical paper. You guys see this, and for some reason the voice recorded for this was not correct, and this actually shows the effort to write a paper in 2017, co-authored with Qualcomm, Cadence, and Synopsys, leading by Intel. That was a good starting point, and they have some limitations. And actually, the paper information was focusing on some fixed information. It was not much possible to grow it. That was the reason that we try to get to the standard. And because we have now here, we had just the work of 4 companies, and also it did not address accuracy, completeness, and quality of the collaterals. And that was one part that did not have the correct voice on it. And also one of the slides somehow was missed. I don't know why. And here, actually, these are the objects created for SA-EDI. And you guys saw this slide, and then, as I mentioned, actually the security annotation information are not currently given to the integrator as within the bundle. And then with this standard, we can actually give that information to the integrator, and these are the security object. These are the SA-EDI objects which are actually generated and given to the integrator. That's then yes, I just noticed this during the presentation. And also, I think with respect to the timing, also I noticed that we had some of the slides started a little bit later. Yes, then so I know I apologize for that. We have to fix it. But that's here what you guys see. Then altogether, the intention is when you guys have an IP, this security related information using this SA-EDI annotation to be generated and given to the integrator, and integrator can actually use that information to check if the security claims are in place, or they can enhance them with their own security requirements, and then use them. That's then this is very handy. And about the database that you guys ask about, you know that this database has a pointer to CWE, and then it can have pointers to other security weakness databases, as I mentioned. And then, as again, like with respect to the asset definition, this is something that the IP designer should actually determine what are the assets. And with respect to the corresponding CWEs, it can be done manually. If the tool has some automation based on the type of the IP that we have, maybe we can associate them with some of these CWEs and then check what are the CWEs actually are applicable. Then I think the EDA tool providers can actually help with this, how much the automation can be achieved for this. And with the rest of the things that here being done, these again that depends upon the capability of the EDA providers. Like when we define the elements, we have some elements, define an element for each asset. We define one element for inputs, one element for output, and but the inputs and outputs are not very well determined. These are just all the sets of all the inputs and all the outputs. Then the tool can actually look at this, and when it generates the APSA object, just determine that what are the actual fan-ins and fan-outs in the RTL that can affect the logic or the or actually allow the asset to be accessed or influence or the asset to be exposed at the output. And that's again some automation that should be taken care of. And also, I think it has been captured in one of the slides here. This is for apps to object. And you know that also we have some conditions actually how that in what condition actually the assets can be exposed or vice versa. Then and this is like the list of the security weakness references that here we have. If we go to the previous one, let me see. You see that for the element objects we have. This is the number 2. Yeah, we have a lot of inputs and output. This one is for the inputs. You see that, and again, this one is for the input. For the other one, okay, coming here. These are like for the inputs, and these are for the outputs. You see that we have 2 sets here, and this is for the input. These are for outputs. Then when we go to the apps to objects, you know that you see that the list for the attack points are much more well defined here. And the tool can do this because for small circuits, maybe you can do it manually. For big circuits, I think we need to have automation for this. As far as I know, this has been implemented or it's supposed to be implemented by the EDA. Yes, that was all about this. Hopefully can help. Also, if you guys want to get more information about the Accellera working group or about MITRE, you guys can reach out to, for Accellera, you guys can reach out to Lynn. The email is here. And that's actually, this is related to the question that one of the audience asked about how to join the group, working group. And then you guys will get the correct information. And with CWE, this is an open forum. As far as I know, there is no charges, I think, to join this MITRE. Again, you guys can reach out to them to get the right information. And the database is already online and free. You guys can use it with respect to this standard. This standard is actually free, and it's available from Accellera. And you guys should go to this link, IP Security Assurance. And there is a white paper about that here as well.
A question?
Yeah.
It seemed like in your examples, you gave some system Verilog expressions that looked like they were properties that you could assert in a formal test. What about CWEs that cannot be tested using SVA or by stating any property?
Yes, actually, this is a good question. At this point, the scope of the work is just to support the ones that can be captured in the RTL. Like if you're looking maybe for the side channel information, probably in the annotation, you guys can capture it, but I'm not sure the tools can process it for you to help you guys with getting more information. Like here, we do not look at the power and the ground, the voltage that you have from power and ground, or the current through them. to actually see if there is a side channel through those. And then the scope of this revision is just to consider the issues that you may face within the IP, and but it covers a very big range of the issues. And also suppose that you have maybe like an optical subsystem maybe on your chip that you cannot represent well with RTL, then you have to take maybe that part off and then just model the related part in actually the related digital part here. If you have something in analog, and again, it's not supported at this point. But the methodology is very similar. And I do not know if there is a plan to cover those later or not. Then when we get to the IEEE standard, I think probably we will decide at that point what needs to be done.
How do you, and follow-up question about to CWEs that cannot be expressed as properties. How do you feel about CWE 1242, inclusion of undocumented features?
Yes, and actually that part is like for your IP, you cannot actually do anything about that. And then because like in your RTL, if you have something that's not supposed to be in the design, I'm not sure if you can really catch it unless it can have an effect on the security objectives. Then suppose if you have a hardware Trojan or something that does not affect your inputs and outputs and violate any of your security objectives, you cannot catch them here.
Is the security element extraction process supposed to catch that sort of the issue? If so, how?
Yes, but when you talk about an undocumented feature, even if you want to model it, you have to determine where the undocumented feature has been added and how to locate it. And this is like Trojan detection, and then somehow it's out of the scope of what we are doing here.
Mm-hmm.
And, but here, if you have a if your Trojan can affect the logic somehow, because most of the Trojans do so, and then you can if as long as you affect the security objectives, you can actually find the issues here. And probably you cannot locate it where it is here because you just annotate that what should happen based on your inputs and outputs. Then if your Trojan affects your assets and that you can see the changes at the output, or the Trojan allows the assets to be modified, you should be able to find the issue. If you have a Trojan that, for example, changes, for example, the temperature of your IP, and or create maybe some form of random noise, I think that can affect the functionality of your design, making it unstable. This is not something that you can model it here very easily. Then the intention is to cover a wide range of issues, but as you mentioned, for some of the things in CW, maybe they are not really implementable here. And like if you have changes maybe in firmware, you know that here we do not have anything here to support like issues that you can have with firmware. then the scope is just hardware based here, hardware
Okay.
that you can model using RTL.
Okay, so
Good
it
question.
sounds like the scope of SA-EDI is that it's an IP integrator gets this SA-EDI description from a IP vendor that it trusts enough, and the IP integrator looks through this entire list and makes sure that it's reasonably comprehensive. And when they go through that, that's when they test their understanding of the IP that they've purchased, at least at a surface level.
About the trusting the vendor, I think altogether it comes back to the security claims. Then as long as the integrator is happy with the security claims of the IP vendor, I think they can use this. But as you mentioned, like if you have hardware Trojan or something, then you do not trust your IP vendor at all. And again, you should define what is actually the trust. And the point is, with respect to the security claims, if you can check them if they are in place and they are met, I think you are okay. We do not have any problem. But if you are thinking about having something absolute, I do not believe that even for security there is anything that you can say that we have absolute security and absolute trust. Then yes, as you mentioned.
Oh yeah.
Yes.
Well, I thought it was interesting that you talked about that establishing trust between vendors and integrators is not something that you can address technically. Like that's a social issue. Like it could end the point in chat. Ultimately, you can't even trust your own teams. That isn't wrong. Okay.
I can give you a good example. Like even in software, if you go online and they get a big piece of software and integrate it into your software, and you cannot actually trust it with respect to the security. Maybe with functionality, it will be fine unless you just go over all the lines and understand it well and see if there are any issues. And there are some tools that you can use to actually scan the piece of software to see that if there are any issues, but it's not guaranteed. Then I think the same goes with this. Then I think altogether, like if you get even your IP from a good IP vendor, or maybe IP vendor that's somehow trustable up to some level, you want to check if the security claims are in place. I think this is very good. And also especially that when as an integrator, and maybe you have a different set of requirements that you can check with their claims to see that if they are actually met or not. If they are not met, you can add your own security requirements, and you have the design, and with the tools you can check if they are met. Then you can actually do that. Yes, but those are all good questions.
Yeah, it sounds like you're saying that if any of this security annotation is present, it's a good sign, and it's hard to write these security annotations in a way that is a hostile to the IP integrator, right?
Yeah, not the not hostile. That's actually not desired by the by the IP integrator.
If like
suppose
what if I was a IP vendor and I made a Trojan hardware block, but then I tried to hide it even though I'm delivering SA-EDI? What would I do? How would the IP integrator see what I left out?
Like with respect to the Trojans, as I mentioned, if they are somehow they can be activated somehow through the inputs, or the effects can be reached out to outputs, I think you can catch them here, because that's like simple validation, or maybe security validation, as long as you can determine that how they will affect the output, or maybe what kind of input sequence can activate your Trojan. But if you have something that doesn't use any standard inputs for your design, like suppose that you have a Trojan that can be activated when the chip gets to a specific temperature, or maybe there is some noise to get activated. Because we do not model them at the RTL level, we cannot catch them. If the effect effect on the assets cannot be observed at the outputs. Again, if we can observe them at the outputs, we can have the security requirements here. But anyways, with your tools, you need to have them activated. Then in your RTL model, if with your test benches, if you just write something that you can activate your hardware Trojan, you can try to see if you can check it. But altogether, this is a very big problem, and like with hardware Trojans. And my point is, probably it's better to focus on what you can find much easier. And with others, I do not say that this is not good, but maybe those can be handled later. Yes, as I mentioned here, we just do not look at other channels that for your IP, like the if you have like some noise coming to the chip, it could be a channel, but within the RTL, you just do not have any specific no standard input output to represent those. And also, again, if suppose that you have a Trojan that actually somehow can get some information from your design, and when it's activated, it just tries to send the information out using side channel. Then this is standard at this point doesn't support it. If you want to annotate it, maybe in the next revision, if you guys join the working group, maybe they can think about how to do it. With respect to the representing those in the SA-EDI, I do not see a problem, but with respect to the implementing EDA tools to actually support that, I think this is a big problem. And because as far as I know, there are not commercial tools that actually can detect Trojans and at that level, because or maybe just give a design to them and tell you that, okay, these are the side channels. And researchers are working on these, and maybe they have some prototypes, but again, these are all limited to maybe some academic work. And in future, maybe in 5-10 years, we will have something out. And again, the annotation can be expanded to include those. But the point is, if we want automation, we should wait until we get the proper EDA support to handle those cases, because you can model something, but if you cannot verify it, it's not really very useful.
Yeah, that's a good answer. Thank you.
Yes, but I do not want to make you guys disappointed. These will be coming. And
I'm not disappointed in that answer. Side channel detection is a legitimately very difficult to end, I can't imagine how you could connect this to power annotations or like you get permission domains, what information is permitted to go where. This is a start. I like it.
Yes, and actually, with respect to the power, as you guys know that there is a specific standard to actually verify the power. But then it's not very difficult. Just maybe say that, okay, your IP should have maybe power pins, and say that, okay, if you have maybe a leakage through the power, we should capture it. And if you want to annotate it, it's not a big deal. Because this is just some form of a specification. We want to say that what should happen, what should not happen. But with respect to the implementation, there will be probably a couple of years at least. Some of the tools become commercial. And as far as I know, like in the University of Florida, there are two professors, Sohrab, Mark Tehranipur, and they have been working on CAD for security. If you guys, I do not have the information right now with me, but if you guys search for those, and with respect to the University of Florida, we have initiated like CAD for security that's on Trust Hub. That I can point you to one of those, and then they have listed some of the CAD for security tools that have been proposed by academia or industry, and they can be in different stages, maybe in just in the concept. They have some algorithms or algorithmic solutions, or maybe they have implementation. And with respect to the licensing, again, there are some information. And then like Tortuga Logic has some items there, and because that's a company, and if you guys want to use something from them, I think probably most cases you guys need to go through their licensing. Then my point is the things will be coming, and the good thing is when we have standards for annotation of security, I think it will make things better because we will have some portability. Then if you have the tools, then you can decide which tools we want to use, as long as the EDA vendors have them. And also, I believe that other big vendors, maybe Synopsys, Cadence, and maybe Mentor Graphics, maybe they work on something like with Mentor Graphics. I think we had the presentation of the I showed you guys one of the implementations like methodics. I believe this is now part of Mentor Graphics. Then I believe that first you guys will see some implementations maybe from academia. Then you will see them in some of the tools, maybe from smaller companies. Then probably some of these companies will be acquired by bigger EDA companies, and they will be there if they find them useful. But the point is they will be available at the end to the users. Yes, and also this is very nice that actually we had some implementation for proof of concept for this, thanks to Methodics and Tortuga Logic. Yeah. Okay, then are there any more questions? No questions?
There was one in the chat. Is there any SVA extension plans to be able to specify integrity properties?
Like like if they are with respect to the assets, you can just model them. But if you want to just talk about the integrity in general, I do not believe that you can do this at this point, because when you want to talk about integrity, that also can include like inclusion of Trojans or something that even you cannot detect them. Then altogether, when you want to talk about integrity, I think for you guys define the assets to say that what are the important things that you want to protect. Then with respect to those, as long as you write the proper expressions to see how they can be affected by the inputs, if they have some integrity security requirements, you can do that. And if they are going to be leaked to the output, that could be for the cases that you may have confidentiality requirements. And then altogether the standard supported, but it's not absolute, with some exceptions that I mentioned. Okay, that's thanks everyone for all the interesting questions. Are there any more questions? Okay, no more questions. Okay, we have Aidin. Then it seems that there are no more questions. We can maybe end the session.
All right, sounds
Thanks
good.
everyone for your interest and your time. Please feel free to reach out to us. Thanks.